Hello friends, in this video let us discuss electronic science paper which was conducted by UGC NET. In this video let us discuss 50 questions. All questions were MCQ based questions. Each question carries 2 marks and all questions were compulsory. Starting with first question, what they have given is we have to calculate the current I1 in the following network, that is the current through 3.3 kilo ohm resistor. This question you can solve using nodal analysis or you can solve using source transformation. Let me solve with the help of source transformation. You will be having two practical current source. This practical current source need to be converted to practical voltage source. So you will be having the resistor, that is 47 kilo ohm. Since the current is flowing in downward direction, the voltage polarity, nothing but the positive polarity, should be downwards, and this voltage should be 47 volts. This voltage should be 47 volt because 1 milli multiplied by 47k is 47. Followed by you will be having a dependent circuit, that is 4i1. Followed by you will be having a resistor valued 3.3 kilo ohms. Through this I have to calculate the current I1. This practical current source need to be converted into a practical voltage source. The resistance value is unchanged, that is 10 kilo ohm, and the voltage value is, what is 20 milli multiplied by 10 kilo, it is 200 volts. So you need to calculate the current, that is I1. Let me make use of KVL. If I am moving from plus to minus, I will be assuming it as voltage drop. If I am moving from minus to plus, I will be assuming it as voltage rise. So starting one, it is minus 47 minus 47 times of I1. Now look at over here, each and every resistor is in the order of kilo ohms. Whatever the current I will be getting, the current will be in the order of milliamperes, right? So plus 4 times of I1 minus 3.3 into I1 minus 10k multiplied by I1 minus 200, which is equals to 0. So I will be getting minus 60.3 times of I1, which is equals to, what is 47 and 200? It is 247. It is 247, and the value of I1 I will be getting it as 247 divided by 60.3, which is equals to 4.096 milliampere with a negative sign, because the resistance will be in the order of kilo ohms, the current will be in the order of milliampere. So it is minus 4.096 milliampere. That is option B is going to follow. Now look at over here, based on this circuit you can eliminate option C and option D because the current in this path is negative. So you can eliminate these positive answers. Second question, what they have given is the velocity of propagation in a rectangular metallic waveguide is given by, they have given the 4 expression for Vp. What does Vp stands for? It is phase velocity. We know that always phase velocity is greater than or equals to group velocity. So in the metallic waveguide, Vp is given by omega divided by under root of omega square mu epsilon minus m pi by a the whole square minus n pi by b the whole square. So the option that is going to follow is A. Third question, what they are given is the radiative and non-radiative lifetime of minority carriers in an active region of a double hetero LED are 60 nanoseconds and 100 nanoseconds. The internal quantum efficiency, we know that internal quantum efficiency is given by 60 divided by, what is the total value? It is 160. So what you will be getting is 37.5%. So this value I will be getting 0.375. If I am expressing in terms of percentage, it is 37.5%. So the option that is going to follow is option C. Fourth question, what they have given is in a p-type silicon sample, the whole concentration I can call it as Na or I can call it as P also, which is equals to 2.25 into 10 power 15 per centimeter cube, and they have given intrinsic carrier concentration, nothing but Ni, which is equals to 1.5 into 10 power 10 per centimeter cube. They are asking us to find the electron concentration. The electron concentration is given by Nd, which is equals to N, which is equals to a question mark. We know that from mass action law. From mass action law, Np equals to Ni square. So what is the value of N is my question. N equals to Ni square divided by P. What is the value of Ni square? Ni square is 1.5 into 10 power 10 the whole square whole divided by what is the value of P? P value is 2.25 into 10 power 15. So what is 1.5 square? It is 2.25, right? Next, what is 10 power 10 whole square? It is 10 power 20. 10 power 20 divided by 10 power 15 is 10 power 5 per centimeter cube. Nothing but electron concentration N equals to Nd, which is equals to, able to follow? So the option that is going to follow is option C is correct. Fifth question, what they have given is a signal m of t which is equals to, so the modulating signal is given by Am sine of 2 pi fmt. So what is the value of Fm? Fm they have given as 100. Is frequency modulated by a carrier and the resulting FM signal. So the resulting FM signal I can call it as S of t, which is equals to AC cos of 2 pi fct plus beta times of 2 pi fmt plus beta times of sine of 2 pi fmt. So this equation I have to compare with this one. So I will be getting AC equals to 10 and cos of 2 pi fc equals to 10 power 5 and beta equals to, I will be getting 15, beta equals to 15 and Fm equals to 100, Fm equals to 100 and I will be getting AC as 10. So what is the approximate bandwidth? So the approximation bandwidth is given by bandwidth equals to 2 times of beta plus 1 times of Fm. What is beta? Beta equals to 15. 15 plus 1 is 16. 16 2s are 32. 32 multiplied by 100, which is equals to 3.2 kilohertz. Nothing but option C is going to follow. Sixth question what they have given is, what is the octal equivalent of the given binary number? So the octal equivalent you have to find. If they are asking us to find the hexadecimal equivalent, then you have to group 4 digits. Since they have asked for octal equivalent, you need to group for 3 digits. So this is 371. So this is 371 to the base 8. So they have given the binary number system 371 is octal equivalent. If they are asking hexadecimal equivalent, at that time you need to group for 4 digits. So if you are grouping for 4 digits, you will be getting 9 and F, nothing but F9 in hexadecimal. Able to follow? Seventh question what they have given is, the block diagram given below, you have to write the transfer function for this. So this transfer function is G1 plus G2 because G1 and G2 are in parallel, multiplied by what is the loop gain which is in negative feedback? It is G of S divided by 1 plus G of S times of H of S. So which option you will be getting? You will be getting C of S divided by R of S, which is equals to G1 plus G2 multiplied by G3 divided by 1 plus G3H. Nothing but option D is going to follow. Eighth question, the gauge factor of a resistance wire strain gauge is a measure of, we know that gauge factor which is equals to 1 plus 2 mu, which is a function of, or it is a measure of sensitivity of the gauge. Nothing but option A is going to follow. Ninth question is based on LVDT. The topics from LVDT is very important. They are asking what is the need for differential connection, right? So in the case of LVDT, the sensitivity is of the order of 40 volt per millimeter. Nothing but for every millimeter change in the displacement, you will be getting 40 volts. So sensitivity is very much high, nothing but it is very much sensitive. So why we are going for this method is not for higher output voltage, we will be choosing this one because of phase sensitivity, nothing but the output voltage as a phase which can lead up to a conclusion whether the displacement of the core is from right to left or from left to right. In order to establish a null or the reference point for the replacement of the core, even this option is also correct, nothing but option B and C is going to follow. Say suppose at the reference or at the origin, if it is lying over here, then the output will be 0 volts. If there is a slight displacement towards right, say suppose you will be getting a positive value. If you are displacing towards left, the value will be negative. Able to follow? 10th question is based on microprocessor. What they have told is microprocessor is also known as CPU. CPU stands for Central Processing Unit. We know that CPU is brain or heart of the computer. Brain or heart of the computer. Able to follow? 11th question, if I is a variable, then I++. We know that I++ is post increment operator. So I++ means which is equals to I equals to I plus 1. So what it is doing is I equals to I plus 1, nothing but first the value will be used, later the value of I will be incremented by 1. Say suppose if I am writing plus plus I, it is nothing but pre-increment. First you increment the value of I, then you can make use of the value of I. So you need to know the difference between post increment and pre-increment. 12th question is based on optical fiber. So what they have given is in a single mode fiber, the following characteristics they have given. First two statements is based on V number. So what is the V number they have given is V number is less than 2.405 is a true statement. Second statement what they have given is V number is very much larger when compared to 2.405, which is a wrong statement. And third statement what they have given is core radius is less than 10 micrometer is correct, because the core radius is of the order of 8 micrometer to 10 micrometer. The core diameter, if I am talking, it is less than 125 micrometer. So fourth statement what they have given is attenuation is of the order of 1 dB per kilometer. Attenuation is 0.5 dB per kilometer. So fourth statement is a wrong statement. So statement 1 and statement 3 is correct, nothing but option C is going to follow. 13th question what they have given is in a differential coupler, the power is applied at port 1 and the output is taken at port 2. For the following statements are given, you have to choose the correct one. Coupling coefficient is given by C equals to 10 log of P1 by P4 is correct, and directivity is given by 10 log of P4 by P3 is correct, nothing but statements 1 and 3 is going to follow. So option A is correct one. 14th question, the question is based on AM demodulator. In the case of AM demodulator, we are having three modulation circuitry. The first one is square law detector. The first one is square law detector and the second one is envelope detector. The second one is envelope detector and the third one is synchronous detector. And the third one is synchronous detector. We know that in the case of square law detector, we will be having nonlinear multiplier plus a low pass filter. In the case of envelope detector, we will be having a diode followed by a low pass filter. Right? In the case of synchronous detector, we will be having a product modulator followed by a low pass filter. And in the case of synchronous detector, we will be having clock. That makes the circuit very much complex. In the case of envelope detector, it is the simplest demodulated circuit that is available. First statement what they have given is a linear multiplier followed by a low pass filter is wrong. If it would have been a non-linear multiplier followed by a low pass filter, then this statement would have been correct. Second statement what they have given is with respect to an high pass filter, for demodulation we are not going to make use of an high pass filter. Third statement what they have given is a diode followed by a low pass filter is correct. And fourth statement, if they would have given band pass filter, then this statement would have been correct. Right? So only statement 3 is going to follow, nothing but option B is correct. 15th question what they have given is NAND gate can be represented by. So the symbol for a NAND gate will be like this. So we will be having two inputs, say A and B, output Y equals to A dot B the whole bar. So NAND gate, how I can represent is, you will be having an AND gate followed by a NOT gate. So this is NAND gate. Or one more representation is, you can make use of a bubbled OR gate. So this bubbled OR gate is similar to your NAND gate. Similarly, bubbled AND gate is similar to NOR gate. First statement what they have given is AND inverter gate is correct. OR invert gate is wrong. Bubbled OR gate is correct. Bubbled AND gate is wrong. So 1 and 3 is follow, nothing but option D is correct. Moving on to 16th question, what they have given is, in a 8085 microprocessor, AD0 to AD7 are treated as input as well as output signals. Yes, this is used for multiplexing, nothing but first cycle it is used as address bus. In the next consecutive cycles it will be used as data bus. Second statement what they have given is HLDA is an output signal, true. HOLD is an output signal, false. It is an input signal. SOD is an output signal, is true. In the case of DMA, nothing but direct memory access, we will be making use of HOLD signal and HLDA signals, right? So statement 1, 2, 4 is correct, nothing but option C is correct. 17th question what they have given is, a variable type character indicates the range and number of bits they are telling. We know that character takes 1 bytes of memory, integer take 2 bytes of memory, floating numbers take 4 bytes of memory. So the range will be from -128 to +127, which includes 0 also. So it is going to take both positive number as well as negative number. It is nothing but signed representation. Able to follow? So character is going to take 8 bytes, nothing but 2 power 8, which is equals to 256. So the range is from -128 to +127. Able to follow? So the option that is going to follow is option C is correct. 18th question what they have given is, the hygrometer is an instrument used to measure. First option what they have given is rainfall. So in order to measure the rainfall, what is the instrument we are going to use is, we are going to make use of a rain gauge, or it is also called as odometer. So with the help of rain gauge also you can find the rainfall, or one more instrument is odometer. In order to measure the altitude, we are going to make use of altimeter. Able to follow? Next, in order to find the relative humidity, we are going to make use of hygrometer, nothing but option C is correct. In order to measure the temperature, we are going to make use of thermometer or thermocouple. Able to follow? So option C is going to follow. 19th question is based on All effect. We know that All effect is positive for p-type material and it is a negative for n-type material, or even for metals also All effect is negative. All effect is very much prominent in the case of semiconductor. If you want to detect the type of material, nothing but whether it is a n-type or a p-type, we need All effect. And in the case of metals, All effect is approximately equals to 0 and it is a negative value. Able to follow? So All effect can be used to measure. First statement what they have given is, conductivity of the charge carrier is true. Mobility of the charge carrier is also true. Nothing but you can able to calculate mobility of electrons and mobility of holes. Third statement what they have given is, the number of valence electrons per atom is wrong statement. Fourth statement what they have given is band gap of the material, which is also a wrong statement. So statement 1 and 2 is going to follow, nothing but option A is correct. 20th question, in a JFET, the amplification factor is given by mu, transconductance is given by Gm, and the dynamic resistance is given by Rd. What is the relation between these three things they are telling? We know that mu equals to gm times of rd, nothing but option C is going to follow. 21st question, what they have given is, they have given the band gap you have to arrange in an increasing order. First, let us talk about gallium phosphide. So the band gap is, we are going to represent band gap by Eg. So the band gap is 2.24 electron volt. So the band gap is 2.24 electron volt. In the case of indium arsenide, it is 0.345 electron volt. So in the case of gallium arsenide, so the band gap is of the order of 1.4 electron volt. In the case of silicon, we are very much familiar with silicon and germanium. It is 1.121 electron volt. 121 electron volt. So according to this, if I am choosing, I will be getting option D. Moving on to 22nd question, what they have given is, you have to arrange the correct sequence for converting a low pass analog signal to a digital signal. So we will be having, the first stage is a low pass filter, nothing but we are going to remove the higher frequency components, followed by sampling, followed by you will be having sampling, followed by you will be having a whole circuit, followed by you are going to do quantization. You are going to do quantization. Next will be encoding. So this low pass filter why we will be using is in order to suppress the higher frequency components, also in order to overcome aliasing effect. We are going to make use of encoders. We are going to make use of encoders to reduce bandwidth. This is very, very important. So what is the first step we are going to do? We are going to make use of a low pass filter. Next is we are going to make use sampling technique. So it is 4213, nothing but option C is going to follow. 23rd question, what they are given is, consider the following circuit configuration. They have given common emitter, common base, emitter follower is nothing but common collector, and the fourth statement what they have given is emitter follower using Darlington pair. We know that if you are making use of Darlington pair, gain will be a very much high value, but the drawback of using Darlington pair is you have to give a penalty for input impedance. So what they are asking is, you have to arrange the input impedance or the input resistance in the ascending order. We know in the case of common base, input impedance is a low value, and common emitter it is a moderate value, and emitter follower is I, nothing but input impedance in the case of emitter follower or common collector is I. Since we are making use of Darlington pair, it is less when compared to emitter follower. So it is 2143, nothing but option A is going to follow. And most of the person will be thinking that if you are making use of Darlington pair, you will be getting very much high input impedance. No friends, you will be getting a low input impedance which is less than common collector configuration. Able to follow? So the suitable option that is going to follow is option A is going to follow. 24th question, what they have given is, in a 8085 microprocessor, you will be having a flag registers. You should arrange the flags from LSB to MSB. We know that the flag contents will be something like this. So this is LSB, and from this way if you are moving, you will be reaching MSB. So first flag will be carry flag. So the first one will be carry flag, right? The next flag will be parity flag. The next one will be parity flag, nothing but option D is going to follow. This sequence is same for your 8086 microprocessor also. There you will be having 9 flags, where 6 are user defined flags and 3 are machine controlled flags. How to remember all the flags is, in One Day International, nothing but ODI, Tendulkar scored 0, TSET, all people cried. 25th question, what they have given is, for a given logic families, you have to arrange the propagation delay from increasing order, nothing but lowest to highest you have to write. So we will be having TTL logic family, ECL logic family, low power CMOS and DTL logic. We know that ECL is the fastest logic. The logic which will be having faster or which will be working at a faster rate, their delay will be very much less. Nothing but first we should get ECL. Nothing but we have to hunt for 2. In the case of CMOS family, it is going to have less power consumption. Nothing but the power consumption you can classify into static power dissipation as well as dynamic power dissipation. In the case of CMOS, the static power dissipation is approximately equals to 0 and the dynamic power dissipation is given by FCL VDD squared. So I can tell it is having less power consumption, nothing but more delay will be there. So CMOS will be having more delay. This values you have to remember. So the TTL, it is of the order of 10 nanoseconds and the DTL will be of the order of 30 nanoseconds. And CMOS will be of the order of 50 to 70 nanoseconds. So it is 70 nanoseconds, and ECL which will be of the order of 2 nanoseconds. So based on this, if I am choosing, I will be getting option A as correct answer. 26th question, again match the following. So on the list 1 they have given indirect band gap, direct band gap, laser diode and light emitting diode. On the list 2 they have given gallium arsenide, single cavity, spontaneous emission, silicon. We know that indirect band gap will be employed by silicon and direct band gap will be there for gallium arsenide, and the laser diode will be having a cavity and it is going to obey the principle of stimulated emission, whereas light emitting diode will be operating on the principle of spontaneous emission. So based on this, if I am choosing, I will be getting option D as correct answer. 27th question, match the following. On the list 1 they have given Poisson's equation, Laplace equation, Ampere's law, divergence of the field. So Poisson's law is del square V, which is equals to minus rho V divided by epsilon. This term, when I am equating it to 0, it will be a Laplace equation, and you will be having Ampere's law, which is under a closed integral h dot dl, which is equals to I, or one more equation is curl h equals to j is Ampere's law, curl h equals to j plus dou d by dou t, which is modified Ampere's law. So you have to remember both the point form as well as integral form also. Statement 4, what they are telling is divergence of the field. So divergence is defined as del dot d, which is equals to rho v. What do you mean by d? D is nothing but epsilon times of E, where epsilon is the constant. So I'll be getting del dot E, which is equals to rho v divided by epsilon, which is rho v divided by epsilon naught. So based on this, if I am choosing, I'll be getting option C as correct answer. 28th question, on the list 1 they have given frequency modulation, double sideband suppressed carrier, pulse code modulation, amplitude modulation. On the list 2 they have given balanced modulator. Balanced modulator will be used in double sideband suppressed carrier, and compounding we are going to make use in PCM. Pre-emphasis and de-emphasis we are going to use in order to maintain signal to noise ratio as greater than 1, so that demodulation will be very much easy. And amplitude modulation, the simplest demodulator circuit will be envelope detector. We will be having 3 demodulator circuits. The first one is square law demodulator, and the second one is envelope detector, and the third one will be synchronous detector. So based on this, if I am choosing, I will be getting option C as correct. 29th question, this question is a part of digital electronics. They have given non-weighted code, error detecting code, weighted code and error correcting code. Non-weighted codes are gray code and XS3 codes. Weighted codes are 8421 code, 2421 code, 84-2-1 codes, and etc. Error detecting code is by parity check, and error correcting code is achieved with the help of Hamming code. So based on this, if I am choosing, I will be getting option D as correct answer. Moving on to question number 30, match the following. In the list 1 they have given transducer, in the list 2 they have given what it is going to measure. First statement, what they are given is capacitive transducer. Capacitive transducer is used to measure pressure. Example is microphone. In this microphone, the sound signal is converted into electrical signal. Thermocouple is used to measure temperature, or we are going to make use of thermometer also. Bourdon gauge is used to measure displacement. So for 30th, option D is going to follow. 31st question, match the following. On the list 1 they have given voltage regulated IC, bistable multivibrator, operational amplifier, phase lock loop. On the list 2 they have given figure of merit, common mode rejection ratio, capture range and locking range, flip flop. We know that bistable multivibrator, in this case you will be having two stable states similar to that of a flip-flop. Flip-flop is a bistable element which can store a single bit of information that can be either logic 0 or logic 1. Similarly, in the case of operational amplifier, you will be having many parameters. One such parameter is common mode rejection ratio, which is defined as the ratio of differential gain to common mode gain. If I am expressing in terms of dB, it is 20 log of AD divided by ACM. Able to follow? So operational amplifier is common mode rejection ratio. Phase lock loop, we will be having capture range and locking range, and voltage regulator IC is figure of merit. For 31st question, option B is going to follow. 32nd question, on the list 1 they have given amplitude shift keying, frequency shift keying, binary phase shift keying and quadrature phase shift keying. We know that amplitude shift keying is also called as on-off keying because we will be having only two states, logic high or logic 0. Frequency shift keying will be having two frequencies. One is mark frequency and the second one is space frequency. This is something like dots and dash. In the case of binary phase shift keying, baud rate is same as bit rate, whereas in the case of quadrature phase shift keying, baud rate is half of bit rate. So the corresponding option that is going to follow is option A is correct. 33rd question is based on C programming. If is mapped to else. So these things are conditional statements. Do, it is while. Do while. Switch, case, main, return. So the option that is going to follow is option D. 34th question, match the following: RC coupling, inductive coupling, transformer coupling, direct coupling. We know that RC coupling, in the case of RC coupling, minimum possible nonlinear distortion will be there. If you are making use of RC coupling, so the nonlinear distortion will be less. In the case of inductive coupling, it is low collector supply voltages that can be used in the case of inductive coupling. In the case of transformer coupling, it is for impedance matching, and direct coupling is for ability to amplify DC and low frequency components. So the option that is going to follow is option B is correct. Moving on to 35th question, you have to tell what is the function of assembler, compiler, interpreter and debugger. We know that assembler is going to create machine code, compiler is the one which is going to check for each and every line, nothing but it is going to execute the program line by line, interpreter which is going to create an object file, debugger which is going to find the faults during runtime. So the option that is going to follow is option B. 36th question to 45th question, the questions are based on assertion and reasoning. Moving on to 36th question, what they have given is a reflex klystron may be used as a single cavity. It is a true statement. A single cavity performs both the actions, nothing but catcher as well as buncher. Even this statement is a true. So the reason is giving the proper explanation for assertion. So I need to opt for A. 37th question, what they are telling is linear polarization 0-1 mode is basically HE11 mode. This statement is true. What is the reason they are telling? Linearly polarized mode or strongly guided mode in which transverse electric and transverse magnetic modes do not have identical propagation constant. Even this statement is also correct. So the reason is giving proper explanation. So I need to opt for A. We know that we will be having three kinds of polarization. The first one is linear polarization, second one is circular polarization, third one is elliptical polarization. Also in the case of rectangular waveguide, the dominant mode is TE01 mode and TM11 mode. So these things are very, very important. Moving on to 38th question, what they have given is combinational circuits have no memory or feedback loop they have specified. So we need to know the basic difference between a combinational circuits and sequential circuits. In the case of combinational circuits, you will not be having memory. But in the case of sequential circuits, you will be having memory. The second difference is in the case of combinational circuits, output is function of present input, whereas in the case of sequential circuits, output is a function of present input as well as past outputs. Able to follow? In the case of combinational circuits, feedback will not be there. In the case of sequential circuits, feedback will be there. So based on this theory, let me answer 38th question. Combinational circuits have no memory or feedback loop. This statement is correct, but what is the reason they are telling is the output of the combinational circuits depends on their input as well as previous output state. They are telling this statement is false. This statement would have been right if this is for sequential circuits. So the corresponding option that is going to follow is option C is correct. 39th question, digital baseband modulation is also referred as time division multiplexing. This statement is true. What is the reason they are telling is pulse analog modulation or pulse amplitude modulation is the first step. Nothing but we are going to make use of quantization. Before that, we are going to make use of low pass filter. Nothing but we are going to pass the signal through low pass filter in order to overcome the aliasing effect, and we are going to prefer Nyquist sampling. And the first step is pulse amplitude modulation. This reason is also correct. So reason is giving proper explanation for assertion. So I need to opt for A. 40th question, what they are telling is under certain condition one gets peak response at high frequency in transformer coupling amplifier. This statement is correct, and reason what they are telling is high frequency model of a transformer coupled amplifier is a resonant circuit. Under resonance you will be getting either current as maximum or you will be getting voltage as maximum. Similarly, you need to check for impedance also. 41st question is based on avalanche breakdown. So what they have specified is at high temperature the avalanche breakdown of Zener diode remains constant. This statement is a false statement. At high temperature means free path of electrons and holes are shorter, therefore a large electric field is required, and this process is called as impact ionization. This statement is true. So only reason is correct, assertion is wrong. So I need to opt for D. 42nd question is based on piezoelectric effect. What is the assertion they are telling is piezoelectric transducers are not suitable for ultra low frequency vibration measurement. This statement is true. But what is the reason they are specifying? Piezoelectric materials have a high dielectric constant. This statement is true. So I need to opt for A. Let us know what do you mean by piezoelectric effect. So for the quartz crystal, what I am going to do is I am going to apply voltage across this quartz crystal. So what this crystal will be doing is it is going to vibrate at its resonant frequency. If I am vibrating this material, I will be getting voltage. So this is what I mean by piezoelectric effect. Supply voltage, it will vibrate, or vibrate that material, you will be getting the voltage. So in the case of mobile phones or electronic gadgets, in order to generate clock pulses, we are going to make use of quartz crystal. 43rd question, what is the assertion they are telling is the contents of random access memory, nothing but RAM, is volatile. Nothing but as soon as when there is a power failure, you are going to lose the information. This statement is true. But what is the reason they are specifying is the contents of read-only memory is non-volatile. Nothing but whenever there is a power failure, you can able to retrieve the information. So reason is correct, but reason is not giving the proper explanation for assertion. So I have to opt for option B. 44th question, what they are telling is logarithms are used to change a multiplication or division problem into a simple addition and subtraction problem. This statement is true. But what is the reason they are specifying is the Laplace transform enables the circuit analyst to convert the set of integral differential equation describing a circuit to the complex frequency domain. In the case of Laplace transform, you are going to replace s equals to j omega and then you are going to solve. So this axis is sigma axis and this one is j omega. So this statement is also true, but Laplace transform is not giving proper explanation for logarithms. So directly I can tell I need to opt for option B. For the 5th question, character string paper str acts as a constant pointer to a string. This statement is true. Star p equals to paper, nothing but star means a pointer, p acts as a pointer to a constant string. So for this you comment your answers in the comment section. 46th to 50th question is based on power electronics. If the applied voltage is increased further when an SCR is forward biased, when the SCR is forward biased, what the thing is going to happen is the voltage drop across the junction gets drastically reduced because of forward blocking voltage. So beyond this forward blocking voltage, if you are applying, the diode will be forward biased. So under forward bias, if you are applying further voltage, nothing but it is going to further forward bias more. So the option that is going to follow is option A. In the case of SCR, you need to consider these two terms. One is forward blocking voltage, and in order to reduce this forward blocking voltage, we are going to make use of gate pulse, or we are going to inject gate pulse. So these two topics are very important. 47th question is based on di by dt protection of an SCR. So in the case of SCR, we will be having three protection circuits. The first one is snubber circuit, and the second one is di by dt protection, and the third one is dv by dt protection. So this di by dt protection is also called as over current protection, and dv by dt protection is also called as over voltage protection. In the case of dv by dt protection, we are going to make use of a capacitor, and in the case of di by dt protection, you need to focus on these two terms, that is hot spots or hot electrons. So what do you mean by hot spots? When it is going to create or when it is going to generate, all these things you should remember. 48th question, they are asking the symbol of a track. We know that the symbol for track will be something like this. You will be having the gate pulses over here. So either you can inject the gate pulse or you can withdraw the gate pulse. So this terminal is anode, this terminal is cathode, and this terminal is gate pulse. So track is a two SCRs connected in anti-parallel with common gate. So you are going to have a common gate, and this SCRs are connected in opposite direction. So the option that is going to follow is option A is correct. 49th question, forced commutation is employed when anode voltage is. So in the case of commutation, we will be having two variants. The first one is forced commutation, and the second one is load commutation. In the case of forced commutation, again you need to focus on voltage as well as current. So based on this, the forced commutation is employed when the anode voltage is pulsating. Nothing but option C is going to follow. 50th question, the last question. Till now, if you are not liking my video, please give it a big thumbs up. Also share this video with your friends. 50th question, DAC is a. The symbol for DAC will be something like this. So you will not be having gate pulses. You will not be having gate pulses, or there is no provision of gate pulse. So anode and cathode, it is a two terminal bidirectional switch. So the corresponding option that is going to follow is option A is correct. So you need to remember the symbols of track, DAC, SCR. So this comes under thyristor. So the topics from power electronics are very important. Till now I have discussed 50 questions. To solve more and more previous year question papers, please like this video, share this video with your friends. Also don't forget to subscribe to my channel Craving Gyan, and don't forget to join my Telegram group. Thank you. All the best for your exams.